Yeah, thank you, and good afternoon. Welcome to have you back after lunch. Yeah, I'm telling something about distributed systems, but I had to have this reference if the Euro Clojure is in Berlin, and that's where the title is coming from. Because I think we have too many walls in our distributed systems, and I think most of us develop distributed systems in any fashion, like because I would like to take the broadest possible definition of a distributed system for the sake of this talk, because I tried to strip the example I'm using later on down to something everybody can relate to, hopefully. So a distributed system here is like two or more components running on separate computers connected over network to exchange messages to coordinate their actions. Like, it's not two components running everywhere, not connected or not talking. This is not what I'm talking about. And this most simple example I could come up with is a simple to-do application running in the web browser with a one service backend, for example, to store your to-do tasks in memory, just get rid of the database. As we're a Clojure conference and Clojure community, of course we're using ClojureScript and Clojure for the front end and for the back end. For sake of having a complete example, I say we're developing Reframe, but it really the talk is about the ideas. So don't hang up on the techniques or the libraries I put up there. And from this simple example, I come to this I think most of you know. It's a picture like this. It's an architecture diagram. And the thing I state here is this architecture diagram has one big drawback. It visually shows a border, like here. And we as an industry are so tied to this notion that we even align our teams along this. We have some front-end developers and some back-end superheroines. Like, maybe it's the other way around. Nobody knows exactly. Maybe some of you remember Conway's law, who stated that organizations are deemed to rebuild their organizational structures in the systems they are building. But we're not having a single architecture. We're not having a picture like this. Most of the time, we as developers are working with our systems. This is more or less a deployment diagram. This is a production view of our system. But we as developers, wanting to have REPL-driven development, wanting to have test-driven development, for us, the border isn't in the right place. And I state we should think of distributed systems as one big system, as far out as possible. So drill back in on what in our current context is the thing we really want from our architecture. And I highlighted some of the components and I grayed out others, because in REPL-driven development, when I want to see stuff in the front-end application happen, like I add a to-do item or I delete one, I want things to happen in the back end. I don't want to develop the front end and see if it sends the right message on the API, and on the other side, develop the back end to react on the API only. I want to, and most of the time, I want to do stuff in the front end and see all my message going back down to the server and coming back, and see the whole cycle. This is not just an idea I'm coming up with for the conference. I'm developing Clojure systems for 6 years now, and one of my first mistakes developing a Clojure system was, hey, we're doing unit tests for everything. We're doing a unit test for functions. 6 years ago, we didn't have Clojure Spec, so I was unit testing each block and each function, and even larger blocks. But when we changed, for example, the order of arguments of a function at a point where we broke that chain, it just occurred to us in an end-to-end test running the complete system. And this is a thing I'm trying to address here, and Spec makes this little better, a little easier, because I have fdef for functions and stuff like that. But the basic idea stems from there. And even if you have another context, even if you are a front-end developer, you should also have the possibility to work on what's your concern, and not have the whole architecture in the whole distribution in mind. So in another focus, for example, I just want to mention, I'm not drilling into this, you could use dev cards to develop just the front end in itself. And that's basically what I'm trying to achieve when we're developing our software. We're doing software as a service, so we're having a front-end application. We're having multiple services for this. And the basic idea of what I'm saying, having contextual architecture, is to drive speed of development, to ease the life of our developers. And this is true for a simple dashboard application, but it's also applicable to much more complex systems. This is a project we're also working on. You see that advisories box over there. We'll take this apart in a moment, where we don't deal with WebSocket connected stuff, but this is what most of you would say is a distributed system. Different services in the backend communicating over some event bus here, Kafka. And when we started developing some of these services, we were trying to find the right granularity, because I'm a big fan of separation of concern. And microservice architecture is like the same thing on a different level. Build a service which does exactly one thing and does this thing really good. But the problem is, and we heard it yesterday, we have a little problem with dependencies. Yeah, remember the picture from yesterday, dependency hell, or with fire all over the place. And we had that also. We tried to avoid it from the beginning because we knew the problem. Because of course, all those smaller parts share common code. They share the spec, for example, for what an advisory is in the first place, or you see S3 in two boxes, so they share a library to connect to our data storage. And to avoid this, we grouped several things together, breaking that microservice pattern or breaking that small concern. And what I'm proposing is a way in the Clojure ecosystem, like I'm coming to that in a moment, a way in the Clojure ecosystem to come up with the possibility to get rid of a dependency hell problem for that special use case. So we can really build smaller features. And like like REPL-driven development and test-driven development. This is another thing which I think makes our systems more robust and our architecture better. Because what I'm having here is the feed reader could be really, really simple. It's just a generic feed reader taking any feed and putting it locally in our infrastructure in S3. This has to be really, really robust, and the services after that are under our control, so we could restart them. We just have to make sure that the reprocessing events on the event bus and stuff like that. So I think it's better for the stability of the system, and it's better for development to break things down. But again, developers think as a unit. And I began with showing you that architecture diagram and stating that the diagram leads us to see a border here. And I think part of the problem is coming from that kind of diagrams where we see those little boxes and try to fill these boxes and try to put them together. And the language we're speaking is really determining the way we think, and the graphical language here is not the optimal representation. But fortunately, this isn't our language. This is. And in Clojure, we can get away of these boxes and put stuff together the way we want it. It's just like functional composition. Yeah? No matter where we draw the function from, if it's from this library or from that namespace. So enough of the general idea. I think you get the picture of what I'm trying to achieve. And when I switch to the second part of my talk, how is Clojure helping us? First of all, and really, really obvious is CLJG, which is with ClojureScript and Clojure, in that simple example we're seeing, and in the larger example of what we as a company really are doing, with this combination of languages, we're enabled to use the same language on both platforms. Because in the end, the picture is right. In the end, software is deployed to different computers, and in this case, even to different platforms. But we have parts we share, like Clojure Spec for advisories. And CLJG is our friend. I'm really can't stress this enough, especially for everyone who's developing a library. Because the Reframe guys really did a great job here, because they enabled this front-end technology to run on the JVM in large parts. And they even developed Reframe Test, where you can run your tests in the JVM. So actually, that's the biggest step in this special example to bridge the gap, because you're running on the same system, you're running in the same context. So this is the test case. I'll just run RF test is reframe test. And we're actually rebuilding the structure of what is happening in Reframe. We're dispatching events and waiting for other events to happen. And the interesting thing is what happens when we dispatch this event. Normally, we would handle this event, call a WebSocket, or create a WebSocket request, wait for, or don't wait for a response, depending on whether it's a request which is synchronous or asynchronous. And when the answer is coming back, we're processing this answer. And here we can directly reach from the dispatch function, if we switch out small parts, directly reach into our business logic, completely ditching the WebSocket messages. Big gain, because you see a lot of problems where you're sending stuff from your backend, which just isn't the right granularity for the interface, or you're asking the wrong things from your interface. And when you're developing a new system and developing the API and adding new business logic to your system, this was a great benefit. However, I'm not the only one on the conference saying Spec is a great thing. On the last Clojure D in March or something here in Berlin, we even had a talk from an English guy who said they are generating Swagger definitions from Clojure Spec. And what I'm trying to stress here is we don't need to spec what we had as a border before. We need to spec the WebSocket messages we're exchanging, of course. And we need to document it for others to use our services. But if we leave this part away and reach directly into the business logic or directly into the app state of the front end, we should also have specs for those. And the interesting part is we're reusing specs all over the place, because of course for example, an advisory ID is a special format. Is the same both in the front end and in the WebSocket and in the back end. That's really a thing I can't stress enough, to really spec on all the levels where you have possible breaks in your architecture. And one of those breaks is like the part where we take out the WebSocket and put in another communication mechanism. The same is true if we take out Kafka or RabbitMQ or whatever and connect services directly together. And here, protocols for the win. We can define the necessities we expect from our communication protocols into Clojure protocols and use this to exchange the communication mechanism. We're building our systems based on Mount. You've heard that also yesterday by the Indonesian guys. So it's relatively easy to switch components with state back and forth with that. And I'm just seeing my time. I'm so much faster than in any test run I did. Leaves lot of room for questions. And the biggest gain we got is something we just learned in the beginning of this year. We were trying out stuff with line modules for another project. Like 2 years ago, we had line submodules. Everything was like, this is okay, but it's not the way it should really feel. And the thing is this dependency help problem. We switched from a different project with different Git repositories to a monorepo. And this gave us the possibility, this and line monoliths together gave us the possibility to explode the number of our projects, actually, and to really have one project for one concern. This is absolutely gorgeous, because what line monolith has, what I didn't find in any other place, and that's why I'm really like both scared and both really looking forward to what you told yesterday about dependency mechanism, because we're trying to tamper with the class path here. Because line monolith is giving us the ability to say, please run a REPL for this project, this project, this project, and this project, and leave the rest apart. Because this is the context I'm currently developing in. This is by far the most amazing thing I've seen, and it's really just working like this. So during development, this is actually what we see as developers, and this is actually what I want to see. And I really doubled my speed, because I would like you to find your own borders and tear them down. Like, not with the exact mechanisms I showed you here, but I'm pretty sure you have your own borders and your own ways to work around. Because if you find a unified context or a unified model of your system and take out all the smaller parts you're really interested in, you're so much faster, and it's so much more fun to work on a complex system. That's really great. So the other option is come join us. So it's 20 minutes. I'm finished. Sorry for being way faster. And I did stuff on dev cards. I did stuff on Spark. If you're interested in any of that, I can go on in the question section, because there's another interesting thing. Christoph Grand developed a Spark library, powder keg, and I'm the maintainer for sparkling, and there are different approaches to actually reach the same goal. So you can see it here. So if you have questions on that, feel free to ask also. Thanks a lot.